Hiya, year 8. So we're just going to pick up from where we left off before Christmas. It is basically going to be a normal lesson, but on video instead of in real life. And you'll just have to pause the video at a few different points to do whatever work I'm asking you to do. Okay? So, as always, we're going to start off with our retrieval roulette. So here's your questions. So you're going to have to pause the video now, write your answers in your yellow workbook as always, and then after you've finished, play the video again and I will put the answers up then. Okay, so pause it now. And here's your answers. So hopefully you did that honestly, and now you're going to mark your work. So again, you're going to have to pause the video, mark your answers and fill in any corrections as normal, same way we always do. Okay, so get on with that now. Right, so open your notes at page 30 for me please, and we're just going to recap work done, which was the last thing we were doing before Christmas. So remember the definition of work done. So remember we spent a bit of time learning that. So work is done when a force causes an object to move a distance, and work is also done anytime there's a transfer of energy. So if energy has changed from one form into another, that means that energy has been transferred. Now, this here, very, very important. This is actually going to come up in a couple of the questions from today's work. So I'll refer back to this little bit as well in a wee bit. Now, remember the equation for calculating work done was work equals force multiplied by distance. And whenever we're writing it, we are fine to write it in this format. We don't have to write the full words. And then we always have to make sure we use the correct units. So capital W for work, and that's measured in joules, and we write a capital J for that. Capital F for force, and that's measured in newtons, and that's a capital N that we write on our answers for that. And then small d for distance, and generally measured in meters. It absolutely must be in meters for our work to come out in joules. We cannot put anything else into this equation. Now, the reason I wanted to go back over that, and it was very brief, it was just to remind you of the equation, is because it's going to come up in today's work as well. So if you turn now to page 34, this is the stuff that we're going to be looking at today. So we're going to be looking at power. Now, power and energy are words that are quite often used in place of one another, like in everyday life, but that is wrong. They're not exactly the same as each other. So there's two different definitions that you can give for power. So the amount of work done in 1 second, or the amount of energy transferred in 1 second. So this here is really why people do tend to mix up the power and energy and saying they're the same thing, but they're not. Power really is how much energy is getting transferred every single second. Now you can see here I've added in another little note which says that another definition for this, it can be stated as the rate at which work is done or the rate at which energy is transferred. Rate just means how many of that thing happen in a second. So see, hopefully you can see why they're the same as each other. So the amount of energy transferred in 1 second or the rate at which energy is transferred. It means the same thing. So another new unit for us to learn, power is measured in watts. Capital W that we use for watts whenever we're writing our answers, and you'll be delighted to know another equation to learn. So power equals work done divided by time taken. Oh, I really don't like it whenever equations are typed like this. I've no idea why I did it like this, but if you're writing this equation, power equals work done divided by time taken. Now, do you remember I said I was going to go back to this? Work done equals energy transferred. I've noticed that this comes up in a couple of the questions. So this can be written as power equals energy transferred divided by time taken. Now this here is the way that I will use it most often, but sometimes a question will give you a power and it'll give you a time, and then it'll ask you for the energy that's been transferred, and people sometimes don't see the connection between work done being equal to energy transferred. So if it's helpful, you can rewrite it like this for those questions. Okay. So anytime we have an equation, we always have what our units are. So whenever we're using this equation, power equals work done divided by time taken. Power is measured in watts, and remember capital W for that. Work done has to be in joules. If the question gives you in kilojoules or millijoules or something like that, you will have to change, you'll have to transfer those. and the time in this has to be in seconds. Now, again, if it's in minutes, then you would multiply by 60 to change to seconds. If it's in hours, you would do that twice. You would do, so 1 hour multiplied by 60 would give you that in minutes. Multiply by 60 again would give you that in seconds. Now, because of that, we're going to do a little bit of practice here at converting units. So down at the bottom of page 34, oh, I'm in the way, we need to be able to convert power to and from kilowatts. So it's the same, and we've done this before, it's the same as changing between kilometers and meters. Remember, any unit with a K in front of that means it's 1,000 of that unit. So 1 kilowatt is 1,000 watts. 1 kilometer or kilometer is 1,000 meters. So if you have a value in watts and you need to give it in kilowatts, you divide by 1,000. If you have a value in kilowatts and you need to change it into watts, which is the more likely that you're going to have to do, you have to multiply by 1,000. So for example, 2 kilowatts, if we have to change that into watts, we multiply by 1,000 and we get 2,000 watts. The other way around then, if we have 100 watts and the question's asked us to give it in kilowatts, then we take that number and we divide it by 1,000. Okay, so you've got 6 questions to do here. I'll do the first one with you and then you can get on with the rest yourself. So convert 5 kilowatts to watts. That's going to be 5. Because we're going from kilowatts to watts, we multiply by 1,000. So that gets us 5,000 watts. Remember to put your unit on your answer. Okay, so there's just about enough room for you to do that on this page. You don't need to worry about doing it in your workbook. So pause the video and answer those now. Right, so here's your answers to check then. So we already had this one done. 7 kilowatts to watts multiplied by 1,000, 7,000 watts. 0.2 kilometers to meters multiplied by 1,000, 200 meters. 1,500 watts to kilowatts, so we're going the other way around in these ones. So we're dividing by 1,000, gives us 1.5 kilowatts. 3,700 watts to kilowatts, again divide by 1,000, 3.7 kilowatts, and 9,800 meters to kilometers, divide by 1,000, 9.8 kilometers. So hopefully we got on all right with those, because that's probably going to come up in some of our later questions using our power equation. Right, back to this power equation then. Let's look at how we would set our working out. It is the exact same way that we set our working out for our work done equation, the exact same way we set out our working out for our efficiency equation. We always show full working out in this format. So I'll remind you about it, I'll go through it again. So a kettle takes 3 minutes to do 500 joules of work. What power is the kettle? So remember, the first step is always to list the information that's given to you in the question. So generally I'll read the question through once, and then on my second read through I'll start to list my information, and that helps me figure out what information is there, and then enables me to pick out what equation it is I have to use, because remember, by the end of the year we're going to have loads of equations to be picking from. So I'm going to make my list of information. So a kettle takes 3 minutes. Now the question doesn't even use the word time, so that's why it's so important that we know our units. Now obviously minutes is obvious, it's time, but a lot of the time it doesn't say the word for the quantity it's talking about, so knowing our units is so important for making sure we list the correct information. So time, 3 minutes. But as I'm writing that down, I'm thinking, oh my goodness, that cannot be in minutes in my equation, it has to be in seconds. So this is me changing it into seconds, so 180 seconds. So a kettle takes 3 minutes to do 500 joules of work. So work is 500 joules. What power is the kettle? So power, and we put a question mark beside the thing that we're looking to get. Then, once we've got that done, first step of our proper working out is to write out our equation. So P equals W over T, power equals work done divided by time taken. So that's our second step. Then we basically rewrite our equation, but fill in any numbers that we know. So we know that the work is 500, so we replace work with 500, divided by time, which we know is 180. And I haven't done it here, but like we can still keep writing down power equals the whole time. I sometimes do it and sometimes don't. So fill in the values. Then this would be one you would be allowed to use your calculator for. So 500 divided by 180 gives you 2.77777777. That'll just keep on going. So again, I could have done my P in there. So power equals, And I've just rounded it, you can see here, to 2 decimal places. So I've rounded up to 2.78, and then I've put my unit on of a watt. So power is 2.78 watts. So every single time you're doing your working out, that's the stages that you do. You write out your equation, you fill in your values, you give your answer, and then you put your unit on it. Okay, so there's 2 questions down at the bottom of this page that I want you to complete. So they're partially completed, and I want you to fill in the rest of them. So pause me now and do that. Okay, so pause. Right, so hopefully you have these done. I'm just going to work my way through them. So a boy does 500 joules of work in 10 seconds. What's his output power? So I've started it off. I've done the list of information. Work 500 joules, time 10 seconds. What's his power? Started off with my equation, filled in my values. 500 divided by 10 gives me 50. And I need to remember to put my units on, and that is watts. Okay, number 2, a crane takes 2 minutes to do 8,000 joules of work. How powerful is the crane? That just means to work out the power. So time, 2 minutes, we have to change that into seconds. So to do that, we multiply by 60. So that gets 120 seconds. Start off by writing out our equation, fill in our values. So power equals work is 8,000 divided by the time is 120 seconds. And if we do 8,000 divided by 120, we get 66.6667. So I'm going to go power is 66.7. I'll just go 1 decimal place there, or 3 significant figures. And my unit, watts. Okay, so same again, page 36. There's one more for you to do. Pause me, do that now. And then we'll work through it here. So hopefully you have this done already. So a car transfers 10,000 joules of energy in 30 seconds. How powerful is the car? So I've already listed our 10,000 joules. The time is 30 seconds. And we've listed that we're looking to figure out the power. So start off by writing out your equation. Hopefully everyone has done that. Power's work divided by time. Work 10,000. Time 30. So that gets 333, or did a B there instead of a P? 333.3 watts. If you've rounded yours slightly differently than mine, that is fine, because the question didn't tell us what we had to round to there. Okay, so the next thing in the notes is rearranging the power equation to make either the work done or the time the subject. So for once we had to work out those things. But before we do that, I want us to have a practice at some straightforward questions just using power equals work done over time. So if you turn to page 37, the workbook questions, obviously you're going to be answering these in your workbook showing full working out. And if you make a note of these questions that I want you to do, basically it's questions 1 to 13, but not 3 and 4 because they're the rearranging ones. So question 1, 2, and then 5 to 13. Now you see I have a wee star at this one. That's because that's making use of the whole work done equals energy transferred thing. So a car transfers 5,950 joules of energy in 35 seconds. Find the power. And then there's a wee hint here for you. Work done equals energy transferred. So the work done in this one is 5,590. The time is 35, and you have to calculate the power. Okay, so if you pause the video and answer those now. So let's go over these answers. Hopefully you have answered 1 to 13, but leaving out 3 and 4. So for question 1, the definition of power. I've written out both. You don't have to have written out both. One will do. So power is the amount of work done in 1 second, or power is the amount of energy transferred in 1 second. Or if you've done the rate of ones, perfectly fine. Question 2 then was writing out the equation to use power. If a question's asking me just to write out an equation, it's not asking me to calculate anything, then it's better to write the wordy version of the equation, okay? The alternative would be to write this, but then you would write what all the letters stand for, so it's better just to go for this. Still mark it right if you've written that, but just make a note of that, okay? Then on to the calculations. So in ones like 5, 6 and 7, I haven't made my list of information just because they weren't ones that were put into context. They were just literally a list of information. So for 5, substituting my numbers in, I got 142.9 watts. And your working out hopefully will be set out exactly as mine is for these all. If you've rounded slightly differently, that is fine. Don't let that put you off, as long as it's the same number. You know what I mean? If yours would round to the same as mine, or if mine would round to yours. So if you put 143 there, that would be fine. If you went to more decimal places, that's also fine for now. 6, full working out, and then I got 13.3 watts. 7, here's my working out, and I got 20 watts. Now I know I'm going through these quite quickly, but remember you can pause the video at any time. If your answer's different from mine, then pause and compare and contrast with yours and see who's gone wrong. Could be me. Let me know if I've made any mistakes. It's highly likely. Then 8. From 8 onwards, these were the ones where I did make the list of information because you had to pick that information out from the question. So there's everything there. There's my working out, and I got 833.3 watts. 9 and 10 are here, full working out, 2000 watts, and then 3000 watts for 10. And then 11 and 12, 3.2 watts and 170 watts. Now 13 was slightly more awkward. Let's go through it. So for 13, it gave us the work done, well, it told us the energy that was supplied, which is the same as the work done, 100,000 joules. Then it told us this motor was working for 2 hours. So I've broken this down and done it in a couple of stages. You can do it all in one stage though, that's fine. So 2 hours, I know I cannot put my time in hours into my power equation. I have to put it into seconds. So to go from hours to minutes, think about how many minutes there are in a second, or in an hour. There's 60. So 2 hours is going to be 2 multiplied by 60, 120 minutes. Then we need to go from minutes to seconds. So again, think how many seconds are in a minute? 60. So we have to multiply by 60 again to get 7,200 seconds. So if you've done that all in one step, that's fine. I just wanted to show what was going on here. And then we have to work out the power. So I've substituted my values in with my work done or energy in joules and my time in seconds. And I got 13.9 watts, and I did round that one off. Okay? So ask me any questions about any of those that you don't understand. Let me know if there's any that I made a silly mistake in. And I'll see you next week. Okay? Bye.